One of the areas the ART AI CDT will focus its research on is the field of fair machine learning. Research in the field revolves around the development of quantitative fairness metrics, which attempt to translate fairness definitions to mathematical formats so that we can judge whether the output of an algorithm is fair. In addition, machine learning models are created, which utilize these metrics as means of fairness-adjusted learning constraints to produce what is known as fair classifiers. The aim of this is to ensure we can produce machine learning models whose output or predictions can be considered fair. And we care about fairness in machine learning outputs because of situations such as the Compass algorithm case, which was used in US courts to assess the likelihood of a defendant to reoffend. The problem that was later found was that the algorithm discriminated against historically marginalized groups by, for example, attributing higher risk scores to individuals solely based on the skin color of that individual. Other examples of unfairness include Amazon's recruitment algorithm, which discriminated against women, or the Apple Card case, where the algorithm responsible for adjusting credit limits was again biased against women and offered them significantly lower credit limits than men, even when the two shared the same bank accounts and assets. For these reasons, fair machine learning attempts to create algorithms with ability to predict accurately from data, but also to prevent unfair decisions from occurring. Unfair decisions such as those in the Compass case, for example. However, we are yet to successfully balance these two goals, which is why further research is crucial. In addition, how do we know what is fair in any given context, or which fairness definition to use? Also, how do we translate fairness concepts to quantitative formats so that it can be used in machine learning? And how do we generalize it so that it's applicable to various contexts, so that we don't need a new metric for every challenge? Also, which machine learning model do we choose? And how do we then integrate this metric into the model to ensure its predictive capacities are not crippled? Or how do we ensure this model isn't robust enough so that it can be used as a general machine learning framework? These are just some of the questions the field of fair machine learning faces, and ultimately are the questions some of the research at the ART AI CDT will attempt to answer.